Hello everyone! Today we're going to be taking a look at a kind of nasty calculus problem from the Stanford Math Tournament Calculus Tiebreaker. In fact, this was the last and, in my opinion, most difficult problem of the test, which I ended up having the pleasure of doing. So basically, it wants us to evaluate this pretty ugly definite integral having many e to the x squareds and absolute values of x. So the first thing we want to do is, of course, split up the integral from negative pi to 0 and from 0 to pi in order to take care of that absolute value of x term, which is pretty unwieldy to deal with. So obviously, after we do this, we can just make x the appropriate thing on both the left and right integrals. So we have negative x on the left integral and x on the right integral. And then after this, we can take the first part of it first and try to simplify it. So we have something of this form, and if we substitute in negative x for x, we'll change it into this form by simply flipping around a couple of negative signs. However, note that the top does not change because x squared, negates the negative signs. However, that x near the dx and this x root 2 changes from negative to positive. And of course, the bounds of the integral have to change from negative pi to 0 to pi because we have flipped it. Great. So now going back, we have something of this form, and we've made some progress. The bounds on both integrals are the same, and actually, if you'll notice, the denominators look, kind of similar. So why don't we do the sort of annoying looking step of combining the two? So if we go back, you'll notice that this is simply a sum of two fractions. So we can multiply this part by this part, add that to this denominator multiplied by this part, and then simply divide the entire fraction by these two, giving us this very ugly looking thing with an x still there because that was never part of the fraction in the first place. And so if you expand everything, you will get something looking like this, but it's actually not as bad as it looks, because most of the terms, for example, this negative x root 2 e to the x squared term, we have a negative of that here and a positive of that here. Similarly for this term, we have a negative of it here and a positive of it here. So most of these terms will actually cancel away, and so what we're actually left with is this, which is actually pretty nice. Unfortunately, it still looks extremely annoying to integrate. However, we have a 2 to the x squared in the numerator and the denominator here, and we have a 2 here. And if you don't see it, distributing the x to the numerator might make it more obvious. Now, if you'll remember, the derivative of 2x squared is just 4x, and we have a 2x here, so perhaps we can do a u sub, with u equaling our denominator, e to the 2x squared minus 2x squared. And so now you'll note that if we take du over dx, we actually get what is exactly 2 times the numerator. So if you'll remember how to do a u sub, if we have 2 times the derivative of something, we can substitute it in, but we just got to divide by 1/2 when we do it. And so that's why we just have 1 over 2u here. So it's basically 1/2 of 1 over u. And the bounds of the integral still stay the same. They're from 0 to pi. And so if we evaluate this integral, we'll just get 1/2 ln of u as the indefinite integral. This equal sign probably shouldn't be there, but it's fine. You get the point. And so if we just substitute back in what we had for u, we'll get 1/2 ln of e to the 2x squared minus 2x squared. And so we can just plug our expression in from our bounds of 0 to pi, if you'll remember, since we changed around that negative pi to pi into two integrals earlier. And so we're left with this thing. The right-hand side is just ln of 1, so it all becomes 0. And thus, that is our final answer. It looks a bit ugly, but the process to get there was beautiful. Like and subscribe for more videos like this one.